Can you see? Can you see my hand too?
Let's start, yeah.
Okay.
But can you see the shit? And
So
now
we
you
have
see the
A, B, D, F, I, and U. And we're gonna test.
You can
We're gonna test A.
first hand over here and then move.
Okay, you can put A. Put A. So this is our A.
Wait, you're recording? Oh, yeah.
Now we put our B. So we can see here we have B. Then we have our D. All right. So we have D here. Then we have F. So we can see F and I. Okay. We have I and we have U. So this is our U and this is our configuration. Hello, my name is Nourul Kareem and my student ID is 10888136, and I'm going to explain about the experience in this project. And this project is about we used the purpose is to, like, we have ASL language, American Sign Language, and these letters we have to show them in the FPGA board and display them using. We could have used many things. For example, camera. We could have used camera. We have the option to use flex sensors. So at first we thought we would use camera, and we already bought our camera. And on that first day, when we were starting to do it, we realized that the camera is a bit more difficult to do than with the flex sensors. Then we changed our mind, and we are like, okay, we want to go through the easy path, and we use flex sensors, and we bought 5 flex sensors. So the camera we bought online. I think it was from the Besomi website. From their website we bought it, and also the flex sensors. The flex sensors we bought it from Amazon. So that day we started to work, and then we changed our decision, and we also almost finished our lab phase 1. So phase 1 was all about using solving with the camera. Then we had to change all of the things, and we said that we are using flex sensors, and we had to change the system. Okay, so then flex sensors was easier. And okay, we first of all we thought we will buy 5 flex sensors, but then we only bought 3 because we have only 3 flex sensors, which are pinky, middle finger, and index finger. These are the 3, and we didn't use our ring finger because it was of no use, and we didn't use thumb because it was a bit difficult. So we divided the work into 3. One of our team member, he did the setting of the hardware setup mainly. Other member, he did he did the K-maps, and he figured out like what are the outputs, like 0 0, it will be A, and the matching outputs that we needed. And my purpose, so my thing was I configured the pins and also I connected like pin assignments in the software, and the other thing which I was responsible for the hardware, from the hardware, and I connected to the FPGA board. Okay, so we use the flex sensors, and main purpose is display the recognized letter on 7-segment display. And yeah, we use 7-segment display, basically using the FPGA. So what is our system flow? Our system flow is we first of all the flex sensors. This is where we show, and at the end we will show the final output also, how the final output looks, and I will put the video of the final output as well. And then from flex sensors, we go to voltage divider. Then we have a chip that is called, the chip number is 74HC04, this chip. Then we have the FPGA GPIO inputs and VHDL logic and hex 07 segment display. Okay, why did we use, now these are the connections, and then I want to talk about the pin planner. What is the purpose of the pin planner? So the pin planner is used to connect the VHDL output signals to the correct physical FPGA pin. And we use Cyclone 5 manual to identify which pin were connected. And in the scheme, I have taken a screenshot from the manual. These are the 7 segment this thing, and these are the pin for which are the pins we should put into the software. So on the left side, we can see this is the software, and this is where we assign the pins, and all the pins like V19, these are the things which we needed to do, A, B, C, D, E, F, G, which is coming from the VHDL code. Then the outputs are IPM, IMP, which is the index. Sorry, these are the inputs. The IPMP, these are the inputs, and the outputs are our the letters. Okay, so we used so from the manual we got it. Okay, this is the main purpose of the why we are using pin planner, so that FPGA outputs would appear on the correct display segments. That's the thing. Okay, why did we use Hexzip? This is the first thing. This is a 7 segment display, and this is the first. We can use hex 1, hex 2. It doesn't matter. But if we have like more displays or more segments, then we can use both, like hex 1, hex 2 together. So yeah. Okay. Now to the connection of from the breadboard, from our hardware setup to the FPGA. So we use GPIO 19, 20, and 21. And these are the 3 wires for 3 fingers. And we used the ground and power. Okay. So first of all, when I was connecting the GPIO, the pins into this thing, the location of GPIO 19, 20, 21, at first I just put the name of the FPGA board into the AI, and I said, where are the pin location? Because I couldn't find the location. And then the AI gave me a location, and I connected it, but it wasn't working. And it was actually the opposite. So again, I went to the manual. Later on, I remembered that it's also the thing. The FPGA board is also in the manual, and from the manual, I figured out where is the location. It was actually flipped here and there. That's why that was the main issue. And then I connected the 3.3 volt and ground. 3.3 volt. Why not 5 volt? 3.3 volt FPGA board uses a logic of 3.3 and not 5 volt. And if you use 5 volt, it could damage the FPGA board. So FPGA board works like the brain. Okay, in summary, we can say that we got the output that we wanted, and whatever the inputs we put and the letters are being shown. We have 7 letters. We have I'm sorry, 6 letters. It's A, B, D, F, I, and U. So these are the letters, and the flex sensor that it was able to convert into a reliable digital signals. The last one more thing I forgot to mention is we use the chip, so that because flex sensors gives like 2.4 volt, 1.2 volt. It's not FPGA would not accept it. FPGA would need 1 or 0. So this chip 74H4HC404, this chip is main purpose of it is to like make FPGA requires clean signals, okay, logic 0 or logic 1. So this will convert using the threshold, it will convert the voltage divider output into clean digital logic levels. This is the main purpose. So if we have, it will just convert these numbers to 1 or 0. So finally, FPGA is the main processing unit, and it makes the decision about which letter should be displayed. So this was my experience with this project. I hope this experience will someday be helpful, and it might click on when we do some similar projects. Thank you.